Today, we're going to talk about how to solve equations with variables on both sides, so kind of just touch up on that a little bit, and then we're going to talk about how to handle those nasty fraction problems. So we're going to teach you a neat little trick that'll take care of those fractions for you. So just a reminder, when you're solving an equation, step one is I always distribute first. It makes things so much easier. So when you're doing this, you want to distribute. You always combine your like terms on each side. Again, it makes things easier. Think of combining as recounting. So that doesn't mean you subtract 1 from 6 and 1. Okay, you're just recounting how many objects you got on the left side. So 6 whole numbers plus 1 makes 7. So then you get to 2x plus 7 equals 10 plus x. It's at this point that it really doesn't matter which item you undo. A lot of kids ask me, which one should I move over first? And I don't even like to say that. I say just pick something and undo it to both sides. So you can undo the 2, the 7, the 10, or the x. So let's say a kid wants to undo the 7. That's great. The only rule is if you subtract 7, you need to put it in the correct column over on the right side of the equation. So we want to put 7 underneath 10, and that's why I wrote here that constants get stacked with constants. That means numbers with no letters should go under numbers with no letters. So we never want to stack things in the wrong columns. And we're not going to finish that problem because we're actually going to do 2 of them, so you'll get your practice in anyway. All right, so really quick, if we distribute here, 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 and here, we know 4 times 2 is 8r minus 4 times 8 is 32. 1/7 of 49. This is what we are practicing in class with these fraction problems. Right? We don't need a calculator to do that. You should know that 7 goes into 49 7 times. So this is just 7r. 7 goes into 70 10 times. So that's just 10. I usually do undo a letter on each side, and I try to stick with positive numbers as much as I can. So I'm going to choose to undo 7r to each side, and I get r minus 32 equals 10. And then I have to undo the 32. So it looks like we're going to get 42. So again, in this problem, you don't have any distributing to do, so you can go right to undoing, whatever you feel like. So I know sometimes kids like to add negatives to kind of get the negatives out of the picture. That's fine. So you have 10p equals 8p, 2 minus 1 is positive 1. Then you have to undo 8p on each side. So you end up getting 2p equals 1, then divide by 2. Right? So your answer is just a fraction, it's 1/2. What we're going to find today, and if you take a look at the problems coming up, there's a lot of fractions in these problems. So instead of going crazy and trying to do all this fraction addition and subtraction, because that kind of slows us down, we're actually going to use this little trick called the LCM fraction elimination method. So step 1, you still want to distribute if possible, so I always get my distributive property out of the way. Step 2 is you're going to find the LCM, or the least common multiple, of all your denominators. And the reason it's denominators is those denominators are causing the fractions to occur. So if we eliminate them, we have no more fractions. When you multiply and divide in equations, okay, so I'm going to write an equation here. I'm going to write 4, I'm going to write down that 4 equals 4, and I think everyone can agree that's true. When you add or subtract, you can do it just once per side. So for example, if you want to add 1 on the left, great, but you have to add 1 on the right as well. You want to keep that equation balanced. When you are adding, let's say, 4 plus 2 together, we know that that is 6. If you want to switch gears and do some multiplication or division, it goes both ways. So right now this is true. However, if you add in this, now it's not true. However, since you multiplied by 2, if you multiply these by 2, you end up getting 8 plus 4 equals 12. That is a true statement. And it works the same way if you would have used division. So instead of multiplying by 2, let's try dividing everything by 2 and see if it still holds true. So we'll get 2, 1, and 3. And that is true, that checks out. So kind of the rule that I created for you guys is you can multiply or divide anytime you want by anything you want in an equation, as long as you do the same operation to everything. So for our purposes, to make our lives a little easier, we're going to practice multiplying everything by our LCM. And you know you did this right if you end up eliminating all your fractions. So let's start with an example. The first thing you want to do is, obviously you can't distribute. So because I see some fractions, I just don't feel like working with them right now. So we're going to find the LCM of 2 and 4, which in this case is 4. So what you need to do is we're going to implement that multiplication rule. So I want to see times 4 to everything that we're doing. Times 4, times 4, times 4, times 4. I also want to see, we should be getting used to 4 times 1/2. You want to go ahead and do that cross-reducing trick. That's going to keep your life a lot simpler. So we get 2s plus 1 times 4 is 4. Again, you see a 4 on top and a 4 on the bottom, so let's just reduce those and make it 1s. Minus 6 times 4 is 24. Then we're going to undo certain steps, so I would probably subtract s on each side. Again, it doesn't matter the order you do this. S plus 4 equals negative 24. Subtract 4, you get s equals negative 28. Number 4, we can't do a mixed number times an integer, so we need to change this into an improper fraction. So let's go ahead and make this 12/5. And inside our parentheses, we still have 10x minus 2/3. And over here we have 2/15 x plus 2. So obviously step 1 says distribute if you can. So this is where we kind of do that 12/5 times 10 trick. 5 goes into 10 twice. Now I'm going to multiply 12 times 2 and I get 24. If you do 12/5 times 2/3, again, if you can do this in your head, it's easier, but if you need to write it out, that's okay too. You're going to get 8 over 5. So now we're going to do our LCM trick just because I don't really feel like working with 5 and 15 as denominators. That's going to make a lot of extra work for us. It's going to be a lot easier if we figure out what the LCM of 5 and 15 is. And we know that that's 15. So again, we want to see times 15 times 15 times 15 times 15. So you got to keep that balance across all of them. 15 times 4 is going to give you 360. I'm not going to do 8 times 15 because I'm going to cross reduce as my first step. So now I'm actually doing 8 times 3, and that's 24. I'm again going to cross reduce the 15s. I'm left with 2x. 2 times 15 is 30. It's going to be a lot easier to solve. Just to save space because I'm running out here, we're going to end up subtracting 2x from both sides. We're also going to need to add 24 to both sides. So these go away, these go away. So it looks like I'm going to get 358 equals 54. And then we're going to divide by 358 on both sides. Now you don't need to know what 54 divided by 358 is. No one knows that. But what you should be able to do is reduce. 54 is an even number and can be reduced down to 27. 358 is also an even number, so it can be broken, and I think it's 179. So I probably wouldn't give you a problem that hard on a quiz or a test, but it's always good to push yourself a little bit. We're going to skip 5. We're going to come back to that one. Let's go ahead and do 6. So first step is to distribute 1/3 and also to distribute 1/6. So let's just kind of do that all at once here. 1/3 times C is 1/3 C. 1/3 times 1 is just 1/3. 1/6 times 3, if you think about the cross-reducing trick, 3 and 6 reduce into 1 and 2. So this actually becomes 1/2. 1/6 times 5, you just do 1 times 5, which is 5, and it's still over 6. Those are really easy multiply fractions with whole numbers. So there's a lot of fractions in that problem that I don't really feel like working with right now. So let's go ahead and get the LCM of 3, 2, and 6, which of course is going to be 6. So we're going to multiply everything by 6. And now comes the fun part. Now we get to start cross-reducing. 3 into 6 twice. 2 times 1 is 2c. 3 into 6 twice again, and that's just 2.
Mary Smith, please call extension 1025. Mary Smith, call 1025.
2 and 6 reduce to 3 and 1, so that's 3c. And the 6 is just reduced to 1s, and you're left with 5. You can see that's so much easier to work with. All right, let's subtract 2c on both sides. And while we're at it, let's also add 5 on both sides. Kind of doing 2 steps at once. Oops, this one and this one. 3 minus 2 is just 1. 5 plus 2 is 7. And there's your answer. All right, so number 7 is the last one that we'll do for the distributing part. I want to point out you are distributing negative 1/3, so please be really careful about your signs here. This is going to stay as 3/8, but negative 1/3 times p is negative 1/3 p. Negative 1/3 times 2 is negative 2/3. 1 and 1/6 is probably going to be easier if you just make that 7 over 6, so I usually change those right away. Right, and now that everything's into a fraction, I'm going to apply the LCM rule. So it looks like my numbers are 8, 3, and 6. And so 24 would be the least common multiple. Now keep in mind, if you wanted to use 48 or anything bigger, that'll be fine. You can use any number you want, but I always try to pick the easiest number that's small to work with. So 24 is the easiest one to work with. All right, cross reduce. 8 to 24 goes in 3 times. 3 times 3 is 9. 3 goes into 24 again 8 times, so that's negative 1 times 8, 8p, minus 3 goes into 24 8 times. 8 times 2 is 16. 6 into 24 4 times, that makes 28p. 24 times 6 is going to be 120. I would probably do 9 minus 8 and just get that out of the way. I always try to get down to 2 things per side. And then we just go through and solve it. All right, so you should end up getting 104 over 27, and you can just leave your answer just like that. That is fine. Really quick, I want to talk about special equations. So typically, no solution versus infinite solution equations. And the first thing that we're going to need to do is I need you guys to change this into negative 8 plus 6. So that was a typo in the notes. You go ahead and you do your distributing, get that out of the way. You get 5m minus 35 minus 3m. And then if you combine like terms, you end up getting 2m plus 5 equals 2m minus 35. So right away, you should notice you have 2m on both sides. And when that happens, you're going to get a special solution. It's either going to be no solution or infinite solutions. So if you just kind of take off 2m on both sides, what you don't want to do is you don't want to write 0m because that messes kids up a lot. Really, anything minus itself is just 0. So you're left with 0 plus 5, which is 5. 0 minus 35, which is negative 35. So this should happen. The letters are gone. Like all of a sudden you have no more letters in your problem. And when that happens, you need to write no solution. So this is actually a trick question. So I'm basically telling you, hey, go find a value for m that makes the equation true and no such value exists. So it's going to be a similar circumstance over here. If I do 3 minus 5, I'm going to get 3r minus 2 on the left and 3r minus 2 on the right. And you kind of freeze at that point because you should realize these are the exact same thing. So the 3 r's are going to become zeros. You're going to be left with negative 2 equals negative 2. So the same thing happens where the letters go away, but what's left is a true statement. That is true, whereas this was false. So because it's true, that means there's infinite solutions to this problem. So that means you can pretty much plug anything you want in for r, and it's going to work out. You're going to get the same thing on both sides of the equation. So we just want to watch out for those kinds of problems. You'll see that right up here. This is a special problem. That's why I saved it for last. So it looks like the LCM obviously is going to be 2. So if you go through and just multiply everything by 2, we're going to get rid of those fractions. So you get 5t minus 2t equals 6 plus 3t. So over here I got 3t equals 6 plus 3t. And if you subtract 3t on both sides, you're going to get 0 equals 6. Now, that's not a true statement. The letters are gone, so you're going to write no solution. There is no value for t. That'll work in this problem.